In this video, we're going to take a look at the conditions necessary to use the limit comparison test. For the limit comparison test, we are going to look at two sequences, really, and then compare their series versions. But one of them is going to be part of what you're given, and then the other one you'll have to come up with, just like the regular comparison test. So assume that we take the ratio of these and take the limit as well. Then, and I'm going to say that equals L. So assume that both of these are positive, and that when you take the limit, you get something L. And then there are three conditions. So here's the first one. If this limit is anything that's bigger than 0, then the series involving a sub n converges if and only if b sub n converges. So the way that I think about number 1 is that the series just do the same thing. That's what the if and only if means. It means if b converges, I'm just going to call it b. If b converges, then a converges as well. Or you could do it the other way around. If a converges, b converges. So if b diverges, then a does not converge either. That's what it means. That if and only if makes it strong. So that this is actually the best case scenario that you could have when it's greater than 0, because then you know whether something converges or whether something diverges. So that's the strongest case. Now, I'm just going to say the way to remember this, instead of having to remember all these words, I'd say if L is greater than 0, then both series do the same thing. That's what I'm going to remember for this one. And then for number 2, we have if L is equal to infinity, so if you take the limit and it's unbounded, and you know that a sub n converges, then b sub n converges as well. That one's like a less strong statement, but it still tells us stuff. So then you might be thinking, well, if I knew that A converged, like why would I even? B would normally be the one that you make up or choose to compare to A, but it could be the other way around as well. So just make sure this one's the strongest one. That one's the nicest to have this result there. If L is equal to infinity, I just remember. So like if L equals infinity. And the top one converges, then they both converge. It doesn't tell you about diverging. This one is kind of like a test for convergence. So we don't know, like this one could be inconclusive. If you get the limit equals infinity and the top one diverges, you have no idea. You don't, that's something to remember. Doesn't say anything about diverging. Even though this one doesn't either, it's the if and only if makes it also talk about diverging. So hopefully that makes sense. And then the last one, if L equals 0 and b sub n converges, then a sub n also converges. So this one, bottom converges, that means both converge. And that's the limit comparison test. So make sure you're using these properly. And also, I think when you're doing your assignment, you should just look over this first, and then for every problem that you do, try and remember these rules without looking. And then if you get it, you get it. If you don't, then look at it and use it. So try it without looking, and then look back at it to see if you got it right. All right, I'm going to do examples in different videos.